All right, today we're going to dive into the story behind one of the most iconic charts in all of science, the periodic table. And trust me, it's so much more than just a poster you see in a chemistry lab. It's really a story about how one brilliant mind managed to find order in complete and utter chaos.
But let's start with the huge question Mendeleev was up against, a question that really you can apply to just about anything. How do you possibly find a single hidden pattern when you're just drowning in a sea of random facts? I mean, that was the challenge for the entire world of chemistry back then. You see, to really get the genius of the solution, we first have to appreciate just how big the problem was. In the mid-19th century, chemistry was, well, it was a mess. It was a jungle of disconnected discoveries, a chaos of data with no map to guide anyone. And the scale of this problem, it was just massive. Scientists had managed to identify 63 different elements. So picture this. You've got 63 unique puzzle pieces, but you've no idea what the final picture is supposed to look like. There's no picture on the box. That's exactly what chemists were facing. And in all of this chaos, they really only had one reliable tool: atomic weight. It was the only fundamental thing they could consistently measure for every single element. So naturally, every early attempt to find some kind of system started right there. And this is where our main character, Dimitri Mendeleev, comes in. He looked at this problem and just approached it differently. He didn't just use his mind, he used his hands. He came up with this brilliant strategy to cut right through all the noise. He called it chemical solitaire. Now, it might sound simple, but this was a stroke of genius. He took a note card for each of the 63 elements and wrote down their key properties, their atomic weight, their density, their chemical behavior, basically creating his own custom deck of scientific playing cards. Now, this was way more than just a neat organizing trick. It was a seriously powerful mental strategy. You see, by turning all that abstract data into a physical puzzle he could hold in his hands, Mendeleev didn't have to waste brain power trying to memorize everything. It totally freed up his mind to do the real work, to actually see the relationships, to visualize the connections, and to test out different ideas super quickly. And as he shuffled and arranged those cards, day in and day out, something incredible started to happen. He began to see an underlying order, like a hidden rhythm in the chaos of all these elements. So as he's laying out the cards, just in order of increasing atomic weight, he notices that the chemical personalities of the elements started repeating themselves. A reactive metal like lithium would pop up, followed by a bunch of other elements, and then the sequence would end with a super reactive gas, a halogen, like fluorine. And then, boom, the whole pattern would just start all over again with the next reactive metal, sodium. It was like a musical chorus. This observation, it became the foundation for everything. He formalized it into what we now call the periodic law. The properties of the elements are a repeating or periodic function of their atomic weights. To put it simply, he was hearing a symphony where everybody else just heard static. But this next part, this is what separates Mendeleev from every other scientist who is trying to crack this code. His real genius wasn't just about what he put in his table, but about what he had the guts to leave out. So when the next element in line by weight just didn't fit the pattern he was seeing, he didn't try to cram it in. Instead, he did something incredibly brave. He just left a blank space. He said these gaps weren't mistakes or flaws in his system. No, they were predictions. They were prophecies of elements that he was sure existed but just hadn't been discovered yet. And he didn't stop there. He used the logic of his own table, looking at the properties of the elements around the gaps, to predict the exact characteristics of these missing elements. He was describing, in detail, something no person had ever laid eyes on. Let's take a specific example. He predicted an element he called AQA aluminum, because he knew it had to exist right below aluminum on his table. He predicted its atomic mass would be about 68, its density would be 6.0, and that it would have a really low melting point. He basically put out a detailed wanted poster for a missing element. And here's where it gets incredible. Just a few years later, in 1875, an element called gallium was discovered, and its properties? They were an almost perfect match. The atomic mass was 69.7, and the density was 5.91. His predictions were just stunningly accurate. This was the moment his table went from being just a clever idea to a profound scientific truth. But Mendeleev's confidence in his pattern was about to be seriously tested. You see, The accepted scientific measurements of the day showed that an element called tellurium was a little heavier than iodine, but based on their chemical personalities, Mendeleev knew in his gut that iodine had to come after tellurium to be with the other halogens. A single data point was threatening his entire beautiful pattern.
So what did he do? He made an incredibly bold move. He just swapped them. He decided to trust the overall integrity of his system more than he trusted that one piece of data. He actually went on record and declared that the accepted atomic weight for tellurium had to be wrong.
Now, that little puzzle would actually remain unsolved for the rest of his life. The final proof that he was right would have to wait for a whole new generation of scientists and a discovery that would uncover an even deeper law of nature.
The answer finally came in 1913, almost 50 years after Mendeleev first published his table. It came from a young British physicist named Henry Moseley, who was doing these groundbreaking experiments with X-rays.
What Moseley's work revealed was the true organizing principle of the elements. It turns out it wasn't atomic weight after all, but the atomic number, which is the number of protons in an atom's nucleus. This was the fundamental property that gave an element its identity. And here it is, the final proof. When the elements were organized by this new fundamental rule, tellurium was found to have an atomic number of 52, and iodine has 53. Mendeleev's controversial decision to swap them, based purely on his intuition about the pattern, was proven to be absolutely 100% correct. So, what's the big takeaway from this amazing 19th century story? What can we learn from this way of thinking, what you might call the Mendeleev mindset? Well, it really gives us a timeless blueprint for discovery. First, you have to master your elements, know your subject inside and out. Then, find your core organizing principle. After that, listen for the repeating patterns, the echoes in the chaos. Have the courage to be an architect of the voids, to define what you know is missing. And finally, have the conviction to trust the big pattern, even when one little piece of data seems to say you're wrong.
Mendeleev's story teaches us this incredibly profound lesson, especially for us today in our age of information overload. True genius isn't just about knowing a ton of facts. It's about having the wisdom to arrange them, the insight to see the patterns they reveal, and the audacity to predict what still lies hidden in the shadows.